Thank you. 7.2.3. Um, 7.2.3 talks about how to, there are three cases that we want to test, okay? Let me see. Let me use another color pen. Oh, this one, black, and this. First case. Now I use proper terminology, default statement H1, H0, mu equals to 30. Now this is the one that we did just now. If we want to test whether population mean has increased. Correct, because in the pizza delivery experiment, we wanted to know whether the pizza delivery time is greater than 30 and increased. I don't care whether it's more than 30 and it's very good. I want to show that its service is lousy, I'll make decision. Then we say, oh, okay. What do? We say, oh, okay. If H0 is true, then this is really 30. Then our assumed level of significance is 5%. Just assume. Okay, this is true. Level of significance. Then we say, oh, okay, the 5% and lower means a rare event. Correct? I'm not prepared to accept anything less than 5%. So I say, oh, because I let this be 5%, then this is my critical value. Don't worry too much about the terminology. All I'm saying is that this is the rejection region. Anything bigger than 34.9, I will reject. If not, I will say that the population is. So far, so good. Second case. Can we say that in another experiment, mu 30, if I have this as my alternative hypothesis, this one I want to test whether population mean has, why am I handwriting so crap? Mean has decreased. Which actually means this. When I set up my test, now if, H0 is true, then this is still 30. How can I test? Where is my critical value now? Look, if I test and my X bar is maybe 20, can I conclude that mean is now less than 30? Probably yes, right? So my critical value now is on, or rather my rejection region should be on this side. My 5% has got to be on this side. And I inverse norm 0.05, I should get, because it's symmetrical, I think you can do a quick calculation, this is 25.1. This is my critical value. So far, so good. Okay. Now it's important, I'm going to say it first, later I'm going to write. Can I ask you a question? Think. Okay, later think, and then maybe you can share with my friend. If the mean is 30, if the mean is indeed 30, is it possible that I reject my H0, which means I conclude that mean is 30 wrongly? Is it possible I make a wrong conclusion? Is it very possible? Not very. Is it possible? Is it possible that I make a wrong conclusion? Yes. For sure, because if mean is 30, it's not as if it's not possible to end up here, right? I could get 36, 37, it's just rare. But I could end up there. And then if I end up there, I make a conclusion that mean is not 30, mean is bigger than 30. There is a possibility of a wrong conclusion. Correct? Now, if I conduct 100 tests, 1,000 tests, 1 million tests, out of so many tests, what is the probability of arriving at this wrong conclusion? Don't know, right? I tell you. If I conduct 100 tests, 100 tests, on average, 5 tests, the conclusion will be wrong. Make sense? Don't make sense, right? Don't make sense, oh? Okay, see. Okay, see, sorry. This is your bell curve. Mean is 30. That means mu is really 30. Okay, mu is really 30. Now, when I conduct test, means I conduct x1. First time I order pizza 9 times, divide by 9, take one value. I could end up here, 31.5, whatever, 32, I could end up everywhere, correct? If mean is 30 is a normal distribution, there are more values here, but there will be some rare values beside. Correct? So far, so good. Out of 100 data, it will be well spread like that. Follow so far? Now, because of the way I set up my rejection region, this area, I set it out as 5%. On average, out of 100 tests, 5 tests will end up here. And when it ends up here, I make a wrong conclusion. Follow so far? When it ends up here, I will make the wrong conclusion because if mean is really 30, this is the distribution. And I do 100 tests, 1,000 tests, 1 million tests, 5% of the tests will end up here, in this region. Follow what I'm saying? So actually, there is always a chance of ending up with a wrong conclusion. The wrong conclusion of rejecting H0 when H0 is indeed true. Follow what I'm saying? So, I give you another definition of level of significance. Now, just now I define it very loosely. I say that level of significance is the decision-making rule. Right? 5% was a decision-making rule you decide. But actually, because of this idea, if you set up 5% here, then 5% of the test will end up here, even if the mean is here. Mean is indeed here, 30. 5% is your percentage error. It is actually the probability. So now I'm going to say 5% is the probability of rejecting H0 when H0 is true. Follow so far? 5%, or rather in this case, level of significance, is the probability of rejecting H0 when H0 is true. You read your notes and you realize. Alright? I say one more time, for those who don't get it, one more time. If mu is indeed 30, this is a normal distribution of x bar. There will be many data, or first time, or you end up here, 31, 32, 28, 25, 100 times, 1 million times, surely there will be some extreme values, rare events that end up here. But because you set up your rejection region like that, as long as it's greater than 34.9, you will reject H0. Some will end up here. And once you end up here, you arrive at the wrong conclusion. Correct? Which means you reject H0 wrongly. So, this is the definition. Okay? Okay? With that, then we can talk about last case. What if my objective is not to test whether increase or decrease. My objective is to test whether population mean has
changed. That means I don't care whether it's increased or decreased. I want to check whether it's changed. Okay, so now we do this. Again, if we say if H naught, now this one I need full attention. Again, we need to set up our rejection region. This one very easy. We say, oh, we want to check whether it's decreased. We set up 5%. This is, that means here, 5% of the time, I'll end up with the wrong conclusion. Correct? If my level of significance is 5%, because I want my error to be 5%, therefore, my rejection region is like that, 25.1. Anything lesser than that, I will reject. Anything bigger than 25.1, okay, can. It's not smaller than that. Does it make sense to all of us that if I want to check whether it has changed, my rejection region should be on both sides? Does it make sense? As long as it ends up here or here, I will say, oh, it has changed. In the between, okay, I can accept. So far, so good. Okay? Then you say, okay, so easy. I say, can I? Then I say, this one must be 25.1, this one must be 34.9. Right? Extreme. But be careful. Why? I need to make use of this idea again. The probability of rejecting H naught when H naught is true. Now again, if H naught is indeed true, that means it's 30. Out of 100 tests, you want to have a 5% chance of arriving at the wrong conclusion. But the wrong conclusion can be obtained from here or from here. Follow what I'm saying? The wrong conclusion, if you test or here, etc., etc., correct? If you test, you want 5% of the time, you will end up here. So actually, the 5% cannot be the area of this. 5% must be area of this plus this. You want 5% of the time to arrive at the wrong conclusion. Therefore, this must be 2.5%. This must be 2.5%. Therefore, you inverse norm 0.025 to get a 24.1 here, and you get a 35.9 here. Correct? Yes. Don't have to, for some of us who don't quite get it yet, never mind. It's okay. Just remember this one. I think later on we'll come to examples, it was soon here. Okay? But just remember this one. Okay, done. The 7.2.3 is done. Okay? Then we look at set. Okay, now we look at the notes, okay? Here, this one. That's all I said. Correct? And then this one, I say this one, two-tail test. Then I say this one. I talk about this one, right? I talk about this one. Can? Alright? Remember? Can we, with the level of significance is 5%? Then I talk about, then I'm splitting it up. Okay? Test statistic. We are. Let's give ourselves a mental break. Pause.